Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course. Pop-up blockers. For a website to generate revenue, a webmaster often advertises other products and services, charging fees to the organization that creates these products and services. The only way that an organization can continually advertise on the website is if it is positive, it'll get a certain amount of click-through response for its ads. However, web users quickly learn to define which windows are advertisements and which aren't, so advertisers need to constantly create new and exciting ways to advertise their products. The traditional JavaScript based pop-up windows doesn't do good of a job as it used to, because many web browsers have built-in pop-up blockers, but you will still see tons of them on the internet. Perhaps in other formats such as Flash, they can take their toll on user productivity and can be detrimental to the user's computer. For example, some pop-up blockers, if clicked, force a user to go to one or more separate websites that could have harmful code, or worse yet, the pop-up itself could have malicious code built in. Perhaps the close button within ad launches some other process altogether. Some attackers create entire websites with malicious pop-ups just to infect as many computers as they can. You might ask, why take advantage of users? Some attackers answer, because they are there to be taken advantage of. Not that I condone this behavior, but this mentality is infectious, making pop-ups and other cousins common, so systems administrators should try their best to block pop-ups. One way to do this is with a pop-up blocker. These can be either enabled or added to most web browsers. One of the problem with pop-up blocking is that it might block content that is not an advertising but instead an integral to the actual website. For example, I used to run a bulletin board system that has the capability to let users know that they have new private messages from other users. One of the options is for this alert to show up as a pop-up window, because so many users do not see this alert and instead get a message from the browser that says pop-up blocked or something similar, which can look sort of suspicious to the user. I decided to turn off that functionality and instead let the main page go to the website emails notify the user of new messages. This type of philosophy should be taken into account by webmasters when they define what the purpose of their website will be. Proper website functionality should be integrated directly into the actual web page, because most users ignore pop-ups and consider them malicious and attempt to close them or block them if they aren't otherwise blocked automatically by their browser. When dealing with the previously listed applications and add-ons, pop-up blocking is known as ad filtering, but this can be taken to another level known as content filtering. Content filtering blocks external files that use JavaScript or images from loading into the browser. Content filtering continues to become more and more important as advertisers become more and more clever. Most new web browser versions offer some kind of filtering, plus proxy based programs such as Squid can filter content among others for multiple computers. Of course, advertisers have devised some new tricks in attempt to get past the pop-up blockers and content filters. Flash-based pop-ups, pop-up under ads, dynamic HTML, hover ads, and so on. Advertisers continue to battle for the ad space with smart new ad types, so system administrators should be prepared to update their clients' web browsers and browser add-ons on a regular basis. Data loss prevention systems. Data loss prevention, DLP, is the concept that refers to the monitoring of data in use, data in motion, and data at rest. A DLP system performs content inspection and is designed to prevent unauthorized use of data as well as prevent the leakage of data outside the computer or network that it resides in. DLP systems can be software or hardware based solutions and come in three varieties. Endpoint DLP systems. These systems run on an individual computer and are usually software based. They monitor data in use such as email communications and control what information flows between various users. These systems can also be used to inspect the content of USB based mass storage devices or block those devices from being accessed altogether by creating rules within software. Network DLP systems. These can be software or hardware based solutions and are often installed on the perimeter of the network. They inspect data that is in motion. Storage DLP systems. These are typically installed in data center or server rooms as software that inspect data at rest. Cloud-based DLP solutions are offered by most cloud providers and protect against data breaches and misuse of data. These often integrate with software infrastructure and platform services and can include any of the systems mentioned previously. Cloud-based DLP is necessary for companies that have increased bring your own device BYOD and can store data and operate infrastructure within the cloud. As with HIDS solutions, DLP solutions must be accurate and updated to reduce the number of false positives and false negatives. Most systems alert the security administrator in the case that there was the possibility of data leakage. However, it is up to the administrator to determine whether the threat was real. Securing computer hardware and peripherals. Now that the operating system is better secured, let's talk about securing computer hardware, the BIOS, and external peripheral devices. Securing the BIOS. The BIOS can be the victim of malicious attacks. For mischievous persons, it can also act as the gateway to the rest of the system protected. Otherwise, your computer might not boot, or worse. Following are ways to do so. Flash the BIOS. Flashing is the term that describes updating of the BIOS. By updating the BIOS to the latest version, you can avoid possible exploits and BIOS errors that might occur. An updated BIOS or newer motherboard can also better protect from electromagnetic interference EMI and electromagnetic pulse EMP. All new motherboards issue at least one new BIOS version within the first 6 months of the motherboard's release. Normally you would flash the BIOS first before making any changes to the BIOS configuration. Use a BIOS password. The password that blocks unwanted persons from gaining access to the BIOS is the supervisor password. Don't confuse it with the user password or power on password. Employed so that the BIOS can verify users' identity before accessing the operating system. Both of these are shown in figure 3.1. Because some computers' BIOS password can be declared by opening the computer or either removing the battery or changing the BIOS jumper, some organizations opt to use locking cables or similar locking devices that deters a person from opening the computer. One related note: many laptops come equipped with drive lock technology. This might simply be referred to as an HDD password or similar name. If enabled, it prompts the user to enter a password for the hard drive when the computer is first booted. If the user of the computer doesn't know the password for the hard drive, the drive locks and the OS does not load. An 8-digit or similar hard drive ID can associate the laptop with the hard drive installed. Refer to figure 3.1. On most systems, this password is clear by default, but if the password is set and forgotten, it can usually be reset within the BIOS. Some laptops come with documentation clearly stating stating the default BIOS and drive lock passwords. Change them as part of the initial configuration of the computer. Configure BIOS boot order. Set up the BIOS to reduce the risk of infiltration. For example, change the BIOS boot order boot device priority so that it looks for a hard drive first and not any type of removable media. Disable external ports and devices. If a company policy requires it, disable removable media including the optical drives, eSATA ports and USB ports. Enable the secure boot option UEFI 2.3.1 and higher offer an option called secure boot. This can secure the boot process of the computer by preventing unsigned or improperly signed device drivers and OS loaders. Implementing this may or may not be possible depending on the type of hardware used by your organization. Review hardware documentation and device drivers, and more importantly, test the configuration before implementing this solution. Today's UEFI based systems use a root of trust, which is code usually embedded in hardware in the form of a trusted platform module (TPM) that incorporates encryption in the form of a public key for a system with secure boot enabled to start up properly. Kernel-based operating system drivers must present private keys that match the root of trust public key. This process can prevent a system from being booted by undesirable OSs that can reside on flash drives or elsewhere, and prevent OSs from being tampered with from booting. This tampering might occur in-house or previously while in transit through the manufacturing supply chain. Secure boot, also known as trusted boot, is an excellent method for protecting the boot process. However, if something occurs that causes the boot process to fail, we won't know because the data is stored in the UEFI of the system that failed to boot. More importantly, we want to be sure that secure boot is working properly. Enter the measured boot option. Measured boot takes measurements of each step of the secure boot process. It signs them, stores them, and sends those measurements to an external source such as a remote attestation service. A trusted external third-party system is required for attestation, meaning verification the integrity of the computer in question has been corroborated. Basically, the remote attestation service compares the measurement with known good values. For this information, the remote service can attest to the fact that the boot process is indeed secure, has failed to meet the requirements. Securing storage devices. The storage device is known to be a common failure point because many storage devices have moving parts or use removable media. Storage devices can pose security risks because usually they are external from a computer system and possibly located in an secure area. Also, keep track of removable media can be difficult. Some of the solutions to this include physical security, encryption, and policies that govern the use and storage of removable media. This section discusses the removable storage such as disks and external USB drives, network attached storage, NAS, and whole disk encryption. Hardware security modules take hardware based encryption to the next level. We also discuss the basics of how these HSMS operate. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.